let's talk about the types of questions that one can hope to answer with simulation. Um, some of these questions, based on your network and how much you already know, may not need simulation. But in general, the more detailed a question is, and or the more detailed you need to know about your network and its specifics in order to answer that question, the more you'll probably need simulation. So in general, simulation can help to determine the expected functioning or performance of your network. There can be multiple types of performance that you're interested in, and it can tell you kind of how this performance behaves as a function of various choices in your network, from hardware choices and design choices. So you can think of the performance that you get as being a function of these two interrelated things. But here are a variety of examples of the types of questions that you can think to ask. At a very simple level, we can say what level of polarization stabilization is necessary at a given node or set of nodes, given the attenuation and drift in my No1 fiber network, in order to obtain a given secure key rate. Say that you're wanting to distribute secure keys. So you have a network in this case already in terms of a fiber infrastructure. You want to be able to get a certain key rate. What level of polarization stabilization is necessary? So in this case, your hardware is at least at that level somewhat constrained, but based on the performance of that hardware, what choices in design at the nodes do you have to make in order to get to a certain desired performance? A more complex example where sort of the design and the hardware are a bit more intermingled, and we can make choices of either of them, would be, say that we have the option of various repeater layouts. So we want to design a repeater for our network, and there are various ways of sort of thinking about how to put together a repeater. And a repeater is something that will in general be able to swap entanglement and therefore extend its range. And there's many ways of doing this. So there's a choice of how do we actually want to go about that type of swapping. In general, these will also require one or more quantum memories as subcomponents of the repeater. And so, say you can have a choice of various types of repeaters, and within those choices, there can be several variants of quantum memories that you hopefully have access to. And so you have kind of like a large space of options here. And so the question then would be, given all these options, how do I obtain the maximally successful entanglement swapping given all these choices? And say that you can make some tuning of the memories, for example. What aspects of these memories tend to impact this performance the most, right? And so you can answer both concrete questions as well as sort of begin to ask, what is most important for this? What is most important for this? In order to make maybe higher level design choices. As a last example, on the bottom here, we have one that is less about hardware and more about software, right? So hardware is great, but we also need something to run on that hardware, and a way that our network will decide kind of what to do when and how its given pieces will actually function and communicate with each other. So in this case, we're saying, okay, given that we know that we're going to have a certain amount of quantum resources at a node, i.e., the number of qubits that are available to do something with. How do we best go about, from a protocol perspective, how do we best go about storing distributed entanglements and using them before they decay in an optimal manner, where we sometimes a memory might have to drop a qubit if it's waited too long, how do we actually design the protocol and software logic of our network to be able to use these resources most efficiently and have to drop the fewest number of qubits possible, basically. So as you can see, there's like a wide range of different questions that you can answer or that you can ask, depending on what it is you're exactly trying to answer.